So while you're doing that, tomorrow's exam will be available online on Blackboard from starting at 8 a.m. You could take it whenever you feel, but you have to take it by the end of the day. And once you start it, you'll need to complete it, just like the last one. Then on Monday, again, we'll review Chapter 5 and 6. Today, at some point in time, I'll get the Chapter 7/8 videos up and the PowerPoints on Blackboard, which will be your final. So next week, 2 exams, one on Tuesday, one on Thursday. And that'll finish Chem 1, which seems like we just started it. Brittany, I can't even remember. I made it up 2 days ago. About the same length as the last one. That's what I could say. Same length as the last one. Let me pull it up and I'll let me see here. $22 questions. 22 questions. Is where it's at. And by me going in, it resets everything. So stupid. So give me a second here. You have 2 hours to take it, so it's plenty of time. All right. Yeah, so Tori, I don't know if you need to go over naming acids and bases, if you need to go over the conjugate stuff. I don't know if you need to go over a titration type problem. But I'll go over whatever you guys need to. I gave you the list in the last video. Stoichiometry, limiting reagents, empirical formula. Yep, you got it, Vaughn. Yeah, naming acids is pretty straightforward. So there's 2 types. There's types of acids that contain oxygen and ones that don't contain oxygen. All right. The poor red pen is dying here. All right. If I don't contain oxygen, I need the prefix hydro. Okay, no oxygen. I need the prefix hydro. I take the root of the anion and add ic to it, so hydrochloric and the word acid. If there is oxygen available, okay, there is no hydro, so no hydro over here. All right. Take the root of the polyatomic, sulf. This is sulfuric acid. And the reason it's sulfuric acid, okay, is because this is sulfate. If I'm the 8 ending, I get the ic ending as the acid. So, H2SO3, which is sulfite, okay, this is sulfite, as the polyatomic, the ites get the OUS ending. So this is sulfurous acid. And another key is, in order to be an acid, I need to be in an aqueous solution. So if you look through the PowerPoints, there were a couple PowerPoints that had examples on it. Some had the AQ, some didn't. If it has the AQ, then I'm in water and I am an acid. Okay. So the difference starts without oxygen, with oxygen. Without oxygen, I need the hydro, root, and then ic acid. Over here, I've got to look at the polyatomic. There is no hydro. Put the root. If my polyatomic ends in ate, it's ic acid. If it ends in ite, it's OUS acid. All right, what else? What else? What else? What else? Page 136, 13.9b. Yeah, mass of blah, blah, blah molecules. Dichloral heptoxide. Okay. All right. So, in covalent bonds, when naming them, we use the hept and di and stuff like that. So, what was it? This is 3.19b. Dichloral heptoxide, I believe it said. So dichloral heptoxide is that. Cl2O7. Okay? They want to know the grams for molecules. Okay. So if I'm going molecules, as soon as I see that, I got to think Avogadro's number. All right, so my pathway is going to be this. Molecules to moles, moles to grams. Here I'm going to use Avogadro's number. Here I'm going to use the molar mass. Okay, so they give me so many molecules, 1.83 times 10 to the 24th. Okay, molecules Not molecules, although. All right, molecules. Then 1 mole has Avogadro's number, all right, of molecules, 6.022 times 10 to the 23rd molecules. All right. And then 1 mole, I need the grams of, what's that, 7 times 16 plus, let me get my calculator out here. 91 plus 16. 183. 183 grams. And then we just do the math. Take this, divide it by this, times that. Okay? But that's the setup right there. All right, what else? I just uploaded chapter 7 and 8 in case you guys are ahead of the game or want to get ahead of the game for next week. But, you know, I know you're focusing on this exam and then 5 and 6, but I have them, both the PowerPoints, and I just put the videos up there for you. It's still up on Blackboard, Tori. So that same sheet is still up on Blackboard, so if you'd like to download it and have it, you can have it. Yes, Brittany, in a way where I'll ask, you know, what's your net ionic equation and things like that. So let's kill Vaughn and Brittany's question at the same time here. So let's say I have a reaction of I'm trying to think of a good one. Let's do lead. We always do lead. But PbNO32 plus potassium iodide. Okay, since it's a double displacement, now both of these are aqueous. If you look at your solubility rules, I have a group 1 or a group 17, okay? But a group 1, always going to be aqueous. All nitrates, always going to be aqueous. And what products am I going to get out of that? Well, we're going to switch partners. Lead is going to go with iodine. Potassium is going to go with nitrate. So our products would be potassium nitrate. Okay. Which, it's a nitrate, it's a group 1, it's aqueous, if you look at your solubility rules. And lead to iodide. Okay, PbI2. And it's I2 because lead is a 2 plus. I figured that out from here. Iodine is a 1 minus. Okay. Now, this is my complete ionic equation. I need to balance it. 1 lead, we're good there. 2 nitrates, 1 nitrate. How about a 2 there? 2 potassiums. I need a 2 there, and now we are okay. My K's never touch. All right. So, now, anything that's aqueous, and just aqueous, solids, liquids, and gases stay the same, but anything aqueous will break down into its ion form. So my complete ionic equation would be the following. Pb 2 plus aqueous plus 2 NO3 minus aqueous. So my subscripts in my net ionic come out front as coefficients, plus, this is an aqueous, so that breaks down, 2K plus 2I minus aqueous yields aqueous solution, so breaks down 2K plus aqueous plus 2NO3 minus aqueous. This is a solid, stays completely solid. PbI2 solid. Now, this is known as my complete ionic. This is known as my molecular. Okay. My net ionic, I need to cancel out the spectators. The spectators are ions that appear on both sides as ions. So, my spectators here. On the reactant side, I have 2 nitrates on the products, 2 potassiums, 2 potassiums. They didn't change. They just brought everybody to the party. To write my net ionic, what is left? I have Pb2 plus aqueous plus I, and 2 of them, 2I minus aqueous. That's a terrible 2. Let me rewrite that out. Yields PbI2 solid. Now, if everything canceled out, then there is no net ionic. All we did was make a whole stew of ions. Okay. So in order to do this, you need to have your solubility rules on hand. Questions on this? You got it. If I ask it in the homework, it's fair game for the exams. So that goes from now until whenever you don't have me anymore. Maybe you guys are done with me next week. Maybe you're taking Chem 2. Maybe you'll end up taking Orgo. I don't know. I'm just telling you that's the way it's going to go. I don't try to trick you, okay? I think you've seen that from what we've been doing. What else can I do for you? So you're going to have to do one of these on the exam. You're going to have to do acid-base reaction. You're going to have to do redox. There's going to be empirical formula. There's going to be naming your acids and conjugates. It's all going to be on there. Limiting reagent, net ionic equations. If I'm being honest with you, out of all the Gen Chem 1 exams, this is the one with the most material. All right, the one that students feel is the most difficult. The next one that you're going to take on Tuesday on gases, everyone feels that's the easiest one because it's just a bunch of formulas. I'm not trying to psych you out. I'm telling you that I'm aware that at this part of General Chemistry 1, this is a lot of material that's thrown at us. But if you break it down into compartments, it's all basically the same thing, going through that mole. And that's why it's all there. All right, what else can I do for you? Is there anything else from the videos or the lectures or... Guys, you have to open up all the videos. It's just not the first, 5 things that when you go to the channel. You have to click on all videos. Okay, on there you'll find your gases also, and so there'll be Chapter 5, 6 lectures. There'll be Chapter 7, 8. There's 3, 7, 8 lectures. Well, 7 and 8 is for the final, or the last exam a week tomorrow. You want to focus on 5 and 6. Yeah, all a covalent bond is when 2 or more things are coming together. So in an ionic bond, let me use different colors here. In an ionic bond, there's something that has an electron, okay, and there's something that wants to get rid of one and one that wants the gain. So that's our ionic bond, sodium chloride. The problem is what happens if 2 chlorines come together. If 2 chlorines come together, neither one wants to give up an electron. So what they do instead is share the electron. And I think, as I said in the video, covalent bond was actually the hashtag for my wedding on Facebook, except spelled as my last name instead of COV. Okay. So how many times I need to, or how many electrons I need, essentially, to complete the octet and be happy will determine how many times I bond. Okay, so here and here, and we represent that by 2 lines, also known as a double bond. Okay. Sometimes what happens is during the sharing process, it's not equal sharing. Things on the right-hand side of the periodic table tend to pull electrons closer to it than things on the left-hand side. It's called electronegativity. So chlorine is actually winning the tug of war for the electrons, which makes hydrogen partially positive and chlorine partially negative. And the same thing happens with water. Okay, water shares with two, one of its electrons with a hydrogen, one of its electrons with a hydrogen, but oxygen's winning that tug of war. Oxygen becomes partially negative. The hydrogens become partially positive, which allows it to do something called hydrogen bonding, which is why we have a whole chapter on aqueous solutions. Okay. So what covalent bonding can be really summed up as is a sharing of electrons to complete our bond. What else can I do, guys? All right, cool. All right. Well, I mean, if you do have other questions, please feel free to email me tonight. I'll be up late. Again, you could start the exam starting at 8 a.m. tomorrow to get it out of the way, or you'll have all day to finish it. I think I set it to like 9 or 10 o'clock at night. Okay. Well, if you do need me for anything, again, email me. You'll be fine as long as you did the homework. Okay, you'll be fine. Yeah. So, good luck tomorrow. And I'll see you on Monday for a review for another exam. I know, fun. All right, guys, take it easy.